Welcome to Homework Lib.
This is chapter 35, problem number 4. We have two antennas, A and B. The distance between them is given to us by 120 meters. And then we have a point Q along the extension of the line that connects them to each other. And we, in part A, we are asked to calculate the longest wavelength, lambda, if we have destructive interference at the point Q. If we have destructive interference at Q. So first of all, for the destructive interference to occur, as you know, we have to have the path difference m plus 1/2 lambda, and the longest wavelength would be when m equals 0. So let's look at the path difference for what's given to us in the problem. Oh, okay. We forgot to mention that the distance from the antenna B to the point that we're interested in is 40 meters. So then the entire length would be RA minus RB. So if this is RA, meaning 160 meters minus 40 meters is 120 meters. So this is the difference in path at point Q. Now, when m equals 0, this is going to be equal to 1/2 times lambda, right? Plug in this equation m to be 0. So then if we multiply 2 by 120 meters, then it's 240 meters. If our wavelength is 240 meters, we get the destructive interference at Q. Now in part B, we are asked to calculate the, again, longest lambda. This time we want constructive interference at Q. Interference at Q. So now when that's the case, as you know, the path difference has to be equal to m times lambda. And in order to find the longest lambda, we're going to have to take it m equals 1. When that's the case, then the path difference doesn't change, right? It's the same, RA minus RB for both cases. It's 120 meters. This is going to be equal to m equals 1. So then this is directly going to be equal to lambda. In this case, well, your lambda is 120 meters.